Welcome to this lesson, and we'll be looking at the origin of oxygen in the Earth's atmosphere, or the origin of the Earth's current atmosphere. So, Earth was formed around 4.5 billion years ago, along with the Sun and other planets, from a nebula. And during this formation, small bodies called planetoids accreted together to form planets. And the first atmosphere of Earth was sort of similar to that of a star, because hydrogen and helium were the main components of the first atmosphere of Earth. But these two gases were lost to the space mainly because of two reasons. The first one is that the gravity of the Earth was not strong enough to hold the hydrogen and helium, which are lighter elements, in the atmosphere. And the second reason was that after the origin of the planet Earth, around 30 million years after that, the Earth was struck by a large object, which later became the reason for the formation of the moon. So that event resulted in the destruction of the primary atmosphere, the first atmosphere of the Earth. So after that event, this is an artistic representation of that, and after that event, for a long time, the Earth was being bombarded with particles of varying sizes. So when this planet, or when this celestial object collided with Earth, a lot of debris were ejected outwards, and some of these particles started orbiting Earth, and later it became Moon. And some of the other particles were falling down to Earth, and these made the Earth sort of like a hellish situation, because since the surface of Earth was extremely hot because of all these bombardments, and a lot of volcanoes were present at that point of time. And slowly the Earth started to cool down, and a second atmosphere started to form. The second atmosphere, the composition of second atmosphere was mainly the result of volcanic activity in Earth at that point of time. So mostly the atmosphere was composed of water vapor and carbon dioxide and nitrogen. So mainly the water vapor was around 80%, roughly 10% carbon dioxide and a few percent of nitrogen, and trace amounts of carbon monoxide, hydrochloric acid, hydrogen sulfide, SO2, etc. were also there. And these were the composition, and this is the composition of the second atmosphere. And in the second atmosphere, virtually no oxygen was present, mainly because the rise of the second atmosphere was due to the volcanic activity, and in volcanic eruptions, the amount of oxygen that is being released is very little. And since there was no oxygen, there was no ozone layer either, and the Earth was being flooded by ultraviolet radiation. And since there was a huge influx of water vapor, and later as the Earth cooled down, this water vapor condensed, and it resulted in the formation of the oceans on Earth. And at that time, the Sun was around 30% weaker than current Sun, but the Earth didn't froze over, or the temperature was not that low. And the reason being the amount of carbon dioxide. So there was a lot of carbon dioxide in the atmosphere, and there was a strong greenhouse effect, so the Earth didn't freeze over at that point of time. So, and after this, the oxygen became a major player in the atmosphere, mainly because, and after the evolution, after the formation of the second atmosphere, there was a little bit of oxygen forming by the splitting up of water molecules in the atmosphere because of the radiation that is coming from the Sun. And the evidence of this oxygen is seen in minor rust in the early period rocks. And this oxygen, the formation of this oxygen, led to a formation of an ozone layer, which prevented the influx of ultraviolet radiation from the Sun, and which later led to the beginning of origin of life on the planet. With the rise of photosynthetic bacteria, the bacteria that can do photosynthesis, and early plants, the oxygen levels began to rise rapidly, and around 2.5 billion years ago, 2.5 billion years ago, the oxygen levels rose to the current levels. So this is a graph that shows the same. So the percentage of oxygen, the percentage of at present 100% being the current level of oxygen in the atmosphere. So this is what as we have seen in the previous slide, as the cyanobacteria or the photosynthetic bacteria and early plants originated, the amount of oxygen in the atmosphere increased rapidly. And while oxygen was increasing, the amount of carbon dioxide was decreasing due to several reasons. So one is that in photosynthesis, CO2 is used to produce oxygen, and some of the carbon which is lost to the system, that is the drop to the bottom of the ocean or it is buried. And chemical weathering, which also removes CO2. Now, chemical weathering is the removal of CO2 from the atmosphere and Earth's crust by this chemical process. The water and carbon dioxide combines to form carbonic acid, and then this carbonic acid will be incorporated as carbonates and into silicate rocks. So, marine organisms, shelled creatures would incorporate this carbonate in their shells, then which would fall into the ocean floor, and then later it would be fossilized, and that carbon will be removed from the system. The bottom line is that the carbon dioxide was being removed from the system. And there were more changes happening. The same thing happened with sulfur and nitrogen also. Sulfur also were taken out of the system in form of acid rain and sulfates as in the ground. And while these gases were decreasing, nitrates were increasing because it was a relatively inert gas, so it was progressively increasing. So the current composition of the atmosphere was established approximately a billion years ago. Then, since the carbon dioxide levels were becoming less and less, the Earth was susceptible to ice ages. When the solar radiation decreased due to the orbital variations in the Earth, as the temperature dropped, Earth began to go into an ice age. And around 750 to 550 million years ago, the Earth cooled down and became nearly entirely glaciated, sort of like an ice ball Earth. And this can, continue for a long time in a feedback mechanism, where with snow reflecting the incoming radiation back, leading to lower temperatures, and which leads to more snow and on and on. So Earth became almost completely glaciated. And how did we get unfrozen? So volcanoes were still putting out carbon dioxide into the atmosphere, and weathering was greatly decreased because water was the main agent of weathering, and weathering was greatly reduced. So CO2 increased until the greenhouse effect was so large, the Earth warmed up and Earth came out of the ice age. The climate, in the last 500 million years, the climate has not been constant. There were periods of ice age and periods of warm periods in the atmosphere, and this was mostly forced by the variation in solar radiation due to periodic changes in the orbital characteristics. This is called Milankovitch cycles, and major volcanic eruption putting up masses of CO2 that caused global warmings. So, is there a possibility of another ice age in the future? That is the next question. So, we are basically in between two ice ages. So, is there a possibility of an ice age in the future? So, we could say that there are less chances now as sunlight or the sun is getting progressively stronger. Also, there is also a human impact. So, probably we will be able to withstand or prevent an ice age because there is a lot of greenhouse gases being put out into the atmosphere by human interactions. So, that's about the origin of the current atmosphere and the evolution of atmosphere of the planet Earth.